Now this is some of the, or one of the extended response questions from the Chapter 1 revision sheet that was handed out for linear equations. A man walks d kilometres. He walks d over 3 kilometres at x kilometres an hour, and then walks 2d over 3, or 2/3 of d kilometres at y kilometres per hour. And the first thing that was asked to find was the time it takes him to walk d kilometres in terms of x, y and d. So basically it's asking you to work out the time, but your answer will be an equation or an expression, not actually a number. So, and the terms that you need to include in your expression is x, y and d. So to work this out, we need to consider a little physics equation where speed is equal to distance divided by time. We can rearrange that to make time equal to distance divided by speed. And for this question, for the different parts of this question, we'll be using a combination of these two variations of the speed equation. So we have our little thing for total time. It's going to be equal to total distance divided by the speed that's travelled. And because we have two different speeds that are being travelled, we will need to have a little sum that we're going to do. So for the total time, will equal the time that they're travelling at x kilometres an hour plus the time that they're travelling at y kilometres an hour, which will be equal to distance over speed for the x component of it and the distance over speed for the y component of it. So for the x component of it, the distance that's travelled is d over 3 is the distance for the x component. So this would be d over 3 divided by x. Okay, that bit there is for the x component of time, plus for the y component of time it's going to be the distance, which is 2d over 3 divided by the time, the speed, sorry, which is y, and that bit there relates to time for y. So rewriting these two expressions here, this will be equal to d over 3x plus 2d over 3y. Now we probably need to see if we can bring that expression for total time into just a single term, or a single fraction if you like. And as I look at this, I notice that I've got 3 as common to the denominators of both those terms. So I'm thinking, what do I need to do to make a common denominator? For the first part, if I multiply the top and the bottom by y, and for the second part, if I multiply the top and the bottom by x, I then end up with two terms which with a common denominator of 3xy. So I'm now going to simplify this to make it dy plus 2dx all divided by 3xy. And that there would be a suitable equation which would represent the total time. Now for the second part of this question, it's asking you to find his average speed in terms of x and y. Now with the equation that we mentioned earlier, the average speed will be equal to the total distance divided by the total time. Now in the first part we actually worked out an expression representing the total time. So we know that from the first part we can use that again. So I'm just going to rewrite this again as the distance, and from the question it says that he walks d kilometres. So that tells us up there that the total distance is d. So this will be equal to d divided by the total time, which was the expression that we worked out in the first part of this question, which is dy plus 2dx divided by 3xy. So it's d divided by all of that. And if you can remember what happens when you divide by a fraction, then you need to flip it upside down and turn it into a times. And so this will be now equal to d times by 3xy over dy plus 2dx. And what I'm going to do is factorise the bottom line there. So this will be equal to d times by 3xy over d's common, and left with y plus 2x on the bottom. Now what I can do is actually cancel down the d on the top and the d on the bottom, and that will leave us with an expression of 3xy divided by y plus 2x. So that there is an expression which is representing the average speed which has been travelled by the guy who's walking. Okay, better go and have a look at what the dog's barking at. Now for this third part, it's now telling us that if x is equal to 2/3 of y, find the time taken, t hours to travel d kilometres in terms of x and d. So this is starting to now turn this into a bit of a simultaneous equations type question, where we've now been presented with a second expression which we'll be able to use to cancel something out. Now we need to keep in mind that the question is asking us to find t in terms of d and x there. So we're going to be looking for some sort of expression saying t is equal to blah 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 x over blah 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 d, or something like that. So the expression that we're provided with there, firstly we need to use the expression from part A. So from part A we had the expression t, which is total time, is equal to dy plus 2dx divided by 3xy. Okay, and we need to keep the x's in the equation, we need to keep the d's in the equation, we need to lose the y's from the equation, and that's where we need to use this equation here. And what we're going to do is we'll rearrange that equation. So if we've got x is equal to 2/3 of y, okay, then we need to rearrange that one, so we need to leave y on its own. So if we multiply both sides of that by 3 and then divide both sides of it by 2, we end up getting y is equal to 3 over 2x. So that's just rearranging the first equation there, timesing both sides by 3, dividing both sides by 2, and that's where we get that. This equation here is now going to be substituted into there. So wherever we see y, we're going to replace it with 3 over 2x. So this will now be equal to d. We've got a y already. So 3 over 2x. I'll just put the 3 over 2 in a bracket there because that's a little fraction that I want to keep as a fraction, plus 2 dx, which is straight down from the top there, over 3x, and then we've got another y here, so we need to have this 3 over 2 fraction and the other x. So in here, this bit here, the 3 over 2x, and this bit here is the 3 over 2x. They are previously y's in that first equation, which has come from there. So we need to keep simplifying this equation. Now it looks a little bit complicated, but we can do it, we can do it. What I'm going to do is just write the top line and the bottom line separately. It's a nice little square bracket. So here we've got d 3 over 2x plus 2 dx divided by 3 over 2x squared. Now where the x squared has come from is we had an x here multiplied by another x here, and they become the x squared on the bottom. Now I'll keep going with this, equal to, top line there. If I look at the top line, I notice that d is common to both terms, as is x common to both terms, so I'm going to factorise that. dx is common, and then I'm left with 3 over 2 plus 2 for the top line, and then this is divided by the bottom line, and I go 3 times 3 is equal to 9, so this will be 9 over 2x squared. I'll write that 2 a bit better there, x squared. Now, we can cancel things down from the top and the bottom, so we have on the top an x, and there's an x squared, so that x will actually cancel down one of these x's from the x squared on the bottom there. So that's going to save us a little bit of grief here. Then the bracket that we have here, we can actually turn that into an improper fraction. So 2 plus 3 over 2 is the equivalent of 7 over 2. So I'll write that as an improper fraction instead there. So we now have, for the top line, simplified as d times 7 over 2 divided by the bottom line as 9 over 2x. And now what I'm going to do is I'll multiply both the top line and the bottom line by 2. So if I times this one by 2 and I times this one by 2, that will cancel that down, and that will cancel that down, and that will leave us with, on the top line here, 7d divided by 9 9x. Or if I rewrite that as a fraction, I'm just going to bring that over to here, so scrolling down. So that will be now equal to t equals 7d over 9x. So that is now our expression of the total time in terms of d and x. For this next part, it's asking us to find x in terms of t and d. So this will be using the equation that we just derived in the previous part, where t is equal to 7d over 9x. Now basically what we need to do is to bring the x to the left hand side and the t to the right hand side. So the easiest way of bringing the x to the left hand side is we're going to multiply both sides by x. And if we times that by x, that will cancel that one down. So we now have xt is equal to 7d over 9. Now to leave x on its own, we just want to divide both sides by t. So we'll divide that by t, and we'll also divide this by t by putting t down the bottom. That cancels that down, which leaves you with a nice little neat expression of x is equal to 7d over 9t. Now that one wasn't too hard. Now for this part here, we need to use the equation that we just determined in the previous part, where x is equal to 7d over 9t. It's asking us to find x if you travelled for 140 minutes in total and covered 6 kilometres. So this tells us that d is equal to 6 kilometres, and it also tells us that t is equal to 140 minutes. Because we're working in kilometres an hour, we have to convert the time to hours. So this will be equal to 140 over 60 hours. Okay, which is going to equal, so the zeros will cancel down, and 2 will go into 14 and 6 to give us a fraction of 7 over 3 hours. Now what we need to do is substitute those two values into this equation. So x is equal to 7 times 6 divided by 9 times 7 over 3. Now looking at this bottom line, the denominator, I can see that I can cancel down that 3 on the bottom with the 9 and leave that as a 3. So this will now be equal to 7 times 6 over 3 times 7, which equals 7 sixes are 42 over 3 sevens 21. 42 divided by 21 is equal to 2. So our answer will be 2 kilometres. That should be kilometres per hour. Make sure I get that right.